Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Hey Houston, we want to look about projectile motion problems. There are many different types. We're going to start with type 1. So the problem that we have is we've got a tennis player. So if you're looking at the paper, if you don't have the paper, sorry about that, but I think if you're going to get the idea, we've got a tennis player, a diagram, it's the tennis player, and he hits a ball, all right, but he's starting the ball at a height of 1.42 meters. And he hits it perfectly horizontal. So the ball, if you will, it'd be a parabola, I didn't do a very good job drawing the parabola, is going to go straight and then fall to the ground. Get the idea? So this is going to be, the resultant vector is going to be right here. And he hits it at 37.2 meters per second. And now we have 3 questions to answer. Hang time, so time. How long is the ball in the air? What is the displacement? Meaning, how far did it travel in the x? How far did he hit it, right? So this is the distance, right? And what is his final velocity? Now that's the question they're asking. Now let's identify our variables. So let's think about this in the x and the y. So we've got d and vx and v and vy. And we've got time. So what do we know? What do you know? D sub x equals question mark. I don't know that. D sub y, that's 1.42 meters. The velocity in the x direction, I know that, that's 37.2. The velocity in the y direction, that's going down, initially is 0. And the time is question mark, because that's one of the questions we want to ask. So we're going to find these answers. By these are the same number, right? And time, displacement. Now when we say displacement, we're looking for d of x, and we're looking for the final velocity. Oh, we didn't do that. So the final velocity, now this is the final velocity as it hits down, so that we should say v final x and v final y. And these are also ones we don't know. Equals question mark, equals question mark. All right, so let's solve one problem at a time. R. So problem number 1, let's solve for the time. So the time has to do is the time that it takes for it to fall. Remember we talked about how the fact that they're independent. If he's at 1.42 meters above, we can just do a free fall problem because the velocity initial in the y direction is 0. So this is simply dropping the ball. Remember, if I drop the ball or hit the ball, it will land at the same time. So we're going to use the equation, right? If you recall, d is equal to v initial, and this is in the y direction, times t plus 1/2 at squared. Now we know one other thing. I should note a. When we're just say g because it's acceleration of gravity. And we know this distance, so this is 1.42. The initial velocity in the downward direction is 0, so this whole term drops, is equal to, and I'm going to say 9.8 over 2, acceleration of gravity is 9.8 times t squared. So I'm simply going to solve for t using this equation. Actually, we should make a note. This is negative 9.8 because it's plus negative because it's going in the negative direction. But we're going to solve this problem. So 1.42, so I'm going to simplify. 1.42 is equal to 4.9 t squared. Divide both sides by 4.9, right? So I'll take on my calculator 1.42 divided by 4.9, and that's 0.28. So t squared is equal to 0.289, really almost like 0.3. I'll take the square root of that answer, and I get t to be equal to 0.54 seconds. So t, this is important, is 0.5, I'll put it over here, 0.54 seconds. That's going to be important because it's going to help us solve these other problems. Make sense? So let's solve the second problem, if you will, number 2, displacement. Now remember, he's traveling at 37 meters per second, so how far is he going to travel? This is finding the dx, how far did the ball hit? guys, this question number 2 is super simple. Velocity is distance over time. And since the x and the y, let's call it the v of x, is independent, we know v of x, 37, so I can say 37.2 is equal to d divided by my time, which was 0.54 seconds. I now rearrange and I solve for d, and that's going to just be 37.2 times 0.54, and I get the d to be equal to 20, almost exactly 20 meters. So this is going to be d of x. This is 20 meters. Now we might need this. We're trying to find the final velocity. Now the final velocity you might think is at 37. What's going on? Because it's hitting this. Let's think about this one. So let's do number 3. So number 3, this becomes a geometric. Let's erase. Let's now look and solve for the final one. This is the more difficult of all the problems, I think, in this particular type 1 problem, this horizontal hitting of the ball. What's going to happen here? So we've got, but it lands further. So this is going to be, if you will, we've got 2 vectors, right? And we need to figure out what this vector is here. So this is, so we know Vx to be 37.2, but this is an accelerating situation. So this is going to be a bit of a weird problem, right? So we're going to pull from our bag of tricks and look at the list of equations that we learned earlier in our conversation. And we can say that if you will, v2y squared is equal to vi, or v1, if you will, squared, plus 2a delta d. I'm trying to find what is the velocity in the y direction, right? So the initial velocity is 0, and this is the final velocity in the y direction. So we're going to say 2 times a, acceleration, which is 9.8, times the change in height, delta d, which is 1.42 meters. So then I plug this into my calculator, and I will get a square. So let's do this, sorry. 2 times 9.8 times 1.42, and this gives me 27.8 is equal to v final, or I sometimes call it 2 squared, and I'll take the square root of that, right? Second square root, second previous answer, and I get v final to be 5.3 meters per second. So the velocity he's going to hit, now we have some simple algebra or Pythagorean theorem. So if this is 37 and this is 5.3, we're going to just solve for the hypotenuse of the triangle. So I'm going to square this, add them together, find the square root. So I've got that up there squared. That's 5.3 squared plus 37.2 squared. Gets a big number. I'll take the square root of that answer, and I get the final velocity when it strikes. Not a whole lot difference than this, 37.6 meters per second. Now they may ask you one other question, what might be the, and I guess to really be precise, if you want to find the velocity, velocity also has a direction, we need to figure out what this angle is. But the angle is going to be something similar. I mean, this is the opposite over the adjacent, so that's tan. So tan -1 of theta is equal to 5.3 over 37.2. So on my calculator, I'm not going to show it on the calculator, but I'm going to take the second function of inverse tan. I get some parentheses, you may not see this, and I'll just take 5.3 divided by 37.2, close my parentheses, and I get theta to be 8.1 degrees. So he's got, this is his velocity, and you'd say at 8 degrees. That's his velocity, has to have a direction too. So this is type 1, or at least the type 1A problem. We'll look at some more types in subsequent segments. Houston, we got this. Houston, we know. Projectile motion. We'll see you in class.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.